Today we are going to start with a concept of the gravitational potential, right? For gravitational potential, we need to discuss some new concept. So in gravitational potential, the concept of the gravitational potential or the symbol for the gravitational potential will be like this. This phi is actually the symbol of gravitational potential, right? Because we studied about the gravitational field by the name of potential world, you got the concept like this. The concept of the gravitational or the potential energy, you know that the potential energy is due to the position of a body, right? So in this concept we are going to talk about with the reference of position also, like which object is close to the planet, so it has what will be the value of gravitational potential stored in that planet. And if we take a body away from the planet, so what will be the value of gravitational potential at that point, right? So let's suppose if we start from the basic. So first of all, we need to write the definition that what we are going to discuss about in gravitational potential. And in gravitational potential, at least we require 2 point masses. Like we need to take two planets to compare the gravitational potential, right? Just like if we take the body at the ground level in the concept of gravitational energy, and when we try to move that body away from that surface, so your value will increase or decrease according to that, right? So basically for gravitational potential, we just write the definition: the work done in bringing a mass from infinity. Infinity means we are taking any maximum point or the point which is not in our gravitational range, right? If something is out of your range, so it means that is at infinity, right? So the work done in bringing a mass from infinity to that point. So this is the concept of gravitational potential, right? So basically we are going to move object out from the gravitational strength or gravitational field into the gravitational field, right? Okay.
Okay.
This is the concept that we need to discuss today. So basically, if we want to write the gravitational potential energy, so basically your gravitational potential energy will be equals to, right? Or you can just simply use the concept of the gravitational potential energy. This is for gravitational potential energy, and you know that the change in potential energy. So basically, this is our first equation for gravitational potential, because the work done in bringing a mass from infinity to that point, we also discussed that what will be that point. So basically, if we talk from the basics, so gravitational potential energy will be equals to mgh, right? This is the basic formula that we discuss in the concept of potential energy, right? So in potential energy, we are talking about the concept of height or position, but this time we are working with the planets. So basically, the planets have some different dimensions, different dynamics. So we need to discuss according to their property, right? So let's suppose if we consider two bodies or two planets, let's suppose we are having one planet over here and we are having another planet, or let's suppose satellite. Okay. So let's suppose if we are having one satellite, because satellite can be into the gravitational field or it may be out from the gravitational field with respect to the planet. So let's suppose if we consider two different points, that initially satellite is at some point and we are going to move that satellite close to the planet, right? So these are two different points from the planets. So you can see both situations are different. So one point is very close to the planet and second point is very far away from the planet, right? So basically when we are talking about the concept of infinity, so infinity means we are taking the point away from the gravitational field, right? And when satellite is in your gravitational field, so that is very close to your surface, right? So the distance at the infinity will be r2 and the distance close to the planet will be r1. Okay. So now we need to talk about the gravitational potential energy, and from the formula that was written in equation number 1, if you consider the value of r, so basically when value of r will be greater, so your gravitational potential energy will be lower, right or not? Okay, so we need to compare this concept, that what will happen when we are taking the distances with reference to the gravitational potential energy, right? If we take a ball at a very high level from the ground surface, so you know that more gravitational potential energy will store into it. And if we are just taking ball very short distance from the ground, so your gravitational potential energy will be low as compared to that height. Okay, so let's suppose if we take 2 points, so your gravitational potential energy derivation will start like this, that the change in gravitational potential energy will be equals to r2, and we are using minus sign because we know that we are against the direction of gravitational pull. So that's why we are using minus, because we are in the opposite direction of the gravitational pull. That's why, because when satellite is moving from the ground surface, so it is moving away from the earth surface, it means it is moving against the gravitational force, right? And if we subtract that value from the closest point, so your equation will look like this. Okay, and finally if we take a common values from this, so your common values are minus minus will be plus, right? And after taking common, it will be 1 over r1 minus 1 over r2, right? Any confusion?
No.
So this is the difference of the distances. So this is the concept. So this equation gives you the value of change in gravitational potential energy. Sorry, a change in gravitational potential, right? And if you want to find out the clear potential, because this is gravitational potential energy, GPE, and if we want to compare the gravitational potential only, not the energy, so phi is the symbol for gravitational potential, and that will be equals to minus gm over r. So this is the formula for gravitational potential, because we first find out the gravitational potential energy according to the position, just like the simple potential energy concept, and then we apply the concept of only gravitational potential, not energy. So if we want to find out that, so you know that there is a concept of one body, right? We are only using capital M, it means we are only taking the reference of one body, not the two. So for that, our equation will be delta phi is equals to minus gm over r2. And for the other one, and we again need to subtract just like the previous concept. First one is for position number 2, second one is for position number 1, and your change will be equals to minus gm over r2 minus gm over r1. Again, you just take the common values and minus minus will be plus. So potential will be equals to, again the same value, only with the reference of one body, right? So let's suppose if you want, if they ask you to drive the value of the gravitational potential only, so you just take the reference like this. And if they are asking about the gravitational potential energy, so you will drive with the concept of gravitational potential energy, right? Any confusion?
No.
And this concept you can simply consider that it is inversely to the distance, right? Because gm is again the constant value, only the value of r depends upon the gravitational potential. If we take gm as a constant value, right, from equation a, you can simply say that it is inversely to the negative of 1 over r, right? Clear?
Sir, over here you wrote capital R. Is it
Yes,
the same as
yes. If basically when we are
lowercase?
working with 2 points, so we write the reference of small r, right? It's up to you. Capital R is the
Okay.
journal one, right? That is for a single point. Okay, so basically capital R is only for one distance if we are only talking about any single particular point, right? Just like we just marked R1 and R2 for two different points of the satellite. But if we only consider one mark or only one point, so you just take capital R. It's up to you, right?
Okay.
So that is the only difference, but you know that we need to first discuss the difference, that what is the difference and where will be the potential will be higher, right? And one more thing, you just find out that we are using negative sign. Negative sign means the more you are away from the planet, so the more potential you are getting over there, right? Just like the example of rubber band, the formula will be F equals to minus kx, right? So that minus sign also shows you the concept of restoring force, right? So same goes over here. If you are moving very far away from the planet, and from that point, when you start moving into the gravitational field, so your potential will be high, right? Just like the example of the asteroid. If asteroid just start moving from the space towards the earth's surface, so it will turn into a fireball because of that great gravitational potential energy, right? And if you just drop a stone from some height on the earth, so you know that there will be no change in the form of energy, in the sense like it will show or it will convert into a fireball, right? Because at that point your potential energy or your potential gravitational potential is not much very high. Okay, getting that point?
Yes.
So let's suppose if we want to mark a graph for this. So let's suppose if we consider a graph in the sense, because there is a concept of minus sign and we are going to move with the minus sign also, and there will be exponential change in it, right? It will not like the discrete one, like a straight line. So we need to mark a exponential graph over here. Let's suppose on x-axis we are taking a distance r, and on y-axis we are taking gravitational potential, right? So on the upper side we are having a positive value, and on lower side we are having negative value. And let's suppose if we consider two different points on the graph, let's suppose this is r2 and r1. So on the graph, your final graphical representation will be like this. Okay. Or you can also start like this point. Okay. So now you can see that when we are at R2, so the value will be more negative, right? So greater potential will be at R2. And if we consider R1, so your potential will be less as compared to R2, right? Because when you are moving close to the planet, so let's suppose if you take R1 very close to the planet, right? So R2 means, sorry, R1 means very close to the planet, just like the example of satellite. You can see R1 is very close to the planet. So at that point, your gravitational potential energy will not much very high because you are at very low distance, right? So Earth will not apply a very much force to try to pull that satellite into the gravitational field. And the point which is at the maximum point or at the maximum distance from the Earth, so when that body starts to move into the gravitational potential, so it have more distance to cover from the infinity point. Just like the example of the rubber band, if you just stretch the rubber band till 1 meter and the second point or the second rubber band is stretched till 5 meters, 5 centimeter, let's suppose. So you know that when you release the rubber band which is extended till 5 centimeter will give you a greater impact, right? Why? Because distance is very much greater as compared to the first rubber band. So that's why the more gravitational potential energy is stored in the second rubber band as compared to the first one, right?
Yes.
So that's why the point which is far away from the planet will give you greater potential energy. But remember that in the negative sign, we need to mark in on the graph in negative value, right? When we solve the graph, when we solve the question, so you will also get the graph in positive and negative form. So always remember that we need to mark with the reference of negative sign, right? Because negative sign gives you the concept of the restoring force. Initially we only discuss about the concept of that elastic deformation. So in elastic deformation we just learn about the concept of negative sign, but we are not using that in the graph, right? We are only solving with the positive values. But this time at this level we also need to identify the correct direction, that is the negative direction. Okay.
Yeah.
So this is the concept. And this is the graph only for single planet, right? So this graph only shows you the reference for a single planet, right? Okay.
Yes.
Okay, let's suppose if we consider a one graph for two planets. Let's suppose if we are having two surface and we need to find out the potential for two different bodies or two different planets. So for two planets, let's suppose your graph will be different. Okay, so let's suppose if we consider two different points on this graph, one is on x-axis, that is r again, the parameter r, and again on y-axis we are having gravitational potential. Okay, so let's suppose if we are having surface 1 and then surface 2, let's suppose this is the point for surface 1 and this is the point for surface 2. So whenever we are going to mark the gravitational potential over here, so we will move again like in the exponential form like this. And one more thing, let's suppose this is the point where the actual planet is, right? So we can say that when you are moving away from planet number 1, this is surface 1 and this is for surface 2. And let's suppose if we consider the central point, so central point is the body actually which is moving away from surface 1 and moving close to surface 2, right? So the first graph actually shows you that the central point, yellow point, actually moving away from surface 1, moving away from planet 1, and the second curve actually shows you moving towards planet number 2, right? And how this graph actually looks like if you consider the graph for the one planet. So for the one planet, your potential will be greater at a phi 2, that is at point r2, right? So when you are moving away from the first planet, so your gravitational potential is going to be increased with the reference of surface number 1 or the planet number 1. Okay, because you know that now you are moving away from surface 1, so the effect of the planet 1 or the surface 1 is decreasing, right? Because now you are away, or now you are just moving out from the range of planet number 1. Okay, and now you are moving close towards the surface 2, so it means that you are going to move towards the gravitational value of surface number 2. So that's why your graph is starting from the first value, the central point, and now that graph will move towards point number 2. Or if you just take the reference from graph 2 or the surface 2, so you can see there is a great change. If you just mark the value on the y-axis, and from planet 1, change is very less. Okay,